I want you to imagine walking onto the job site of a brand new commercial high-rise. But right away, something feels completely different to you.
Yeah, it doesn't sound right.
Exactly. Instead of that deafening roar of like a dozen concrete trucks lining the block or the constant shower of sparks from steel welders, you're looking up at cranes flying these massive, beautiful panels of engineered wood through the air.
And the smell, too.
Right. The site actually smells like a pine forest instead of exhaust.
Which is wild to experience on a commercial site.
It really is. And, this isn't some experimental architectural concept, and it's definitely not a digital rendering. It is 2026, and wooden skyscrapers are quietly but aggressively taking over the skyline.
They really are.
So welcome to the deep dive. For all the construction business owners tuning in from the Scaling Legends audience, we have an incredibly important roadmap for you today.
It's a big one.
Yeah. We are unpacking the reality of mass timber and CLT, which stands for cross-laminated timber. We're going to explore the structural mechanics of how these materials actually work and address the heavy bureaucracy and safety concerns around wood and fire.
Because there are a lot of those.
Oh, absolutely. And most importantly, we are going to break down the bottom line business case for contractors who want to scale their operations and actually win these massive commercial bids.
Because it is a profound paradigm shift. And honestly, it's happening much faster than a lot of traditional builders realize.
Right.
Like, to set the stage for you here, if you look up north, Canada is currently leading this revolution. They have these towering CLT structures already operating in major cities.
Serving the concept every day.
Exactly, proving the financial and structural viability of the model on a daily basis. But it is rapidly becoming a global standard, and the U.S. market is currently at this massive tipping point.
Yeah.
The contractors who figure out how to bid, sequence, and build these projects today, well, they're the ones who are going to dominate the commercial space for the next 2 decades.
Okay, hold on though. I have to play the skeptic for a second here.
For sure, go for it.
Because I look at the skylines of New York or Chicago or Dallas right now, and all I see are steel cranes and concrete cores.
Fair point.
So if this is such an undeniable revolution, why aren't all my competitors doing it yet? I mean, if you are a traditional commercial contractor listening right now, your brain is entirely wired for steel and concrete.
Right, completely.
So what actually separates mass timber from like the traditional stick framing we use to build a standard suburban house?
It's a great question because the terminology itself can be really deceiving. When people hear the word timber, they immediately picture standard dimensional lumber, your basic 2x4s.
The stuff sitting at the hardware store.
Exactly. But comparing a 2x4 to CLT is completely missing the engineering reality.
Okay, how so?
Think of a single piece of standard lumber, like a handful of dry spaghetti. If you bend it in one direction, it's pretty easy to snap.
Right, breaks right in half.
Yeah, because it has a natural weakness along its grain. It warps, it shrinks, it splits. But cross-laminated timber is totally different. You are taking those dimensional boards and gluing them together in massive layers, but you are weaving them.
Weaving them? What do you mean?
So each layer of wood is oriented perpendicular, like at a 90-degree angle to the layer below it.
Oh, okay, so it's like weaving those fragile spaghetti strands into a really dense interlocking fabric.
Precisely. By alternating the direction of the wood grain at 90-degree angles, you basically neutralize the wood's natural vulnerabilities.
Because they're locked together.
Right. Wood naturally wants to expand and contract across its grain, but in CLT, the perpendicular layer locks it in place. They literally fight each other's weaknesses.
That makes sense.
What you get is a massive, solid panel that has incredible dimensional stability and load-bearing strength on multiple axes. Honestly, it behaves structurally much more like a precast concrete slab than a piece of timber.
Wait, okay. But if you are building an 18-story structure out of wood in a high-wind environment, or, I don't know, a seismic zone like Japan?
Yeah, the sway.
Right. How does the foundation not crack under the sway? How does a wooden skyscraper actually handle those extreme environmental stresses?
Well, what's fascinating here is that the global proof of concept has already answered those structural questions. Like, look at Norway's Mestornet building.
Oh, yeah. I've seen pictures of that.
It reaches 280 feet into the sky. It's an 18-story mixed-use building made entirely of mass timber.
That is just massive.
It is. And in Japan, they're planning the W350 project, which is aiming to be a 350-meter tall wooden skyscraper.
In one of the most seismically active zones on Earth.
Exactly. Australia has International House in Sydney, and the engineering has been proven because of one critical factor.
Which is?
The weight. CLT is incredibly light for its strength.
And that weight advantage is exactly where the daily reality for a contractor on the ground completely changes, right? Because we aren't just talking about like a slight reduction in tonnage.
Oh, not at all. CLT is only 1/5 the weight of concrete.
1/5.
Yeah, an 80% reduction in dead load.
Man, let's translate that for the site superintendents or the project managers listening right now. Think about what that drastic reduction in weight fundamentally changes about your site prep.
That's massive.
If a traditional concrete floor requires 50 cement trucks clogging up downtown traffic for an entire week, a CLT equivalent requires just 10 flatbeds.
Yep.
You aren't just saving weight, you are buying back weeks of community goodwill, you're dodging noise ordinances, and eliminating massive traffic logistics.
And it changes everything beneath the dirt, too, because the superstructure is 80% lighter than a concrete equivalent. Your foundation requirements drop dramatically.
Of course, because it's pushing down so much less.
Right. You don't need to drive piles nearly as deep into the bedrock. You don't need the same massive volume of concrete for the footings.
That's a huge cost saving.
Huge. And in urban infill projects where you are building over existing infrastructure, like fragile subway tunnels or underground parking garages, that weight reduction is often the only reason the engineering of the project is even viable in the first place.
Plus, think about your equipment rentals. If your massive floor panels weigh a fraction of precast concrete or heavy I-beams, you're using significantly smaller cranes.
Exactly.
You're shrinking your site staging footprint. The sheer physical footprint of your operation becomes so much leaner.
It really does.
But this all naturally leads to the elephant in the room.
Yeah.
And it's the exact pushback every single contractor, developer, and city planner is going to face when they try to pitch this to a client.
Wood burns.
Exactly, wood burns. You are building an 18-story skyscraper out of what is essentially campfire fuel.
Right, that's the perception.
But let's look past just the physics of it. Contractors aren't just worried about the science of fire. They are terrified of the bureaucracy of fire.
Oh, absolutely.
Like, try explaining this to a city fire marshal who has spent 30 years signing off on non-combustible steel, or an insurance underwriter who sees the word timber on the application and immediately quadruples your builder's risk premium.
Yeah, it's tough.
How do contractors actually get this past the red tape?
Well, it is the biggest hurdle, and it does require re-educating the bureaucracy. But the data to do that is overwhelming now. We have to look at the science of charring, which provides this completely counterintuitive fire testing data.
Okay, the science of charring. Break that down.
So when you have a massive thick panel of CLT, it doesn't ignite and burn to ash like a standard 2x4.
Right.
Mass timber chars incredibly predictably. In the event of a severe raging fire, the outer layer of the wood does burn, obviously, but as it burns, it creates a dense, carbonized layer of char on the outside.
Kind of like the crust on a brisket.
Yes, exactly like that. And that thick char layer actually acts as a phenomenal insulator.
Oh, really?
Yeah. It physically starves the fire of the oxygen it needs to penetrate deeper into the wood, and it protects the structural core of the panel, allowing it to retain its full load-bearing capacity for hours.
Which is wild to think about. The fire basically creates its own fireproofing.
It does. And we have to contrast that with the materials the fire marshals usually prefer, right? Like steel. Yeah. We tend to think of steel as invincible.
Sure, Superman is the man of steel for a reason.
Right. But under extreme heat, steel does the exact opposite of mass timber. It doesn't insulate itself, it conducts heat.
Yeah.
As it heats up, it loses its structural integrity rapidly and it fails. It warps and buckles catastrophically, often pulling the rest of the structure down with it in an instant.
And concrete has its own issues in a fire, too.
Oh, definitely. Have you ever seen concrete spall in a fire?
Oh, man, yeah. Just to clarify for anyone who hasn't witnessed it, spalling is when the microscopic water droplets that are trapped inside the concrete, they literally boil, turn to steam, expand, and cause the concrete to violently explode right off the rebar. Right?
Exactly. The water expands roughly 1,600 times its volume when it turns to steam.
That is terrifying.
It is. The concrete just violently chunks off, exposing the structural steel inside to the direct flames. Mass timber, ironically, is incredibly predictable and stable compared to both of them in a real fire scenario.
Okay, so here's where it gets really interesting, because the regulatory bodies have finally looked at this science and caught up.
Finally.
Yeah, the United States building codes are notoriously painfully slow to adapt to anything new, but they have officially shifted. The IBC, the International Building Code, in its 2021 update, introduced 3 brand new construction types.
The Type 5e updates.
Right, types IVA, IVB, and IVC. And these specifically address mass timber and officially, legally, allow it to be built up to 18 stories tall in the United States.
This was the floodgate opening for the entire industry.
It really was.
The new codes lay out exactly how much of the wood needs to be encapsulated, meaning covered up in fire-rated drywall, versus how much can be left beautifully exposed based on the height of the building.
Right, the aesthetics.
Yeah. So Type IVA covers the tallest structures up to 18 stories and requires full encapsulation. But Type IVC, for buildings up to 9 stories, allows almost all the structural wood to remain exposed, which is exactly what tenants want.
And the market is reacting to this code change so aggressively. To emphasize that this is a reality you cannot ignore, Smart Business Automator's Market Intelligence Report confirms there are already over 1,600 mass timber projects in the U.S., either completed or currently in design.
1,600?
Yeah, the ceiling hasn't just been shattered. The commercial market is scaling this exponentially.
So with the structural integrity proven and the legal code approval completely established across the country, we have to transition to the bottom line.
Let's do it.
Why should a construction business owner actively pivot their company, retrain their teams, and start bidding on these mass timber projects?
Right, because construction is a brutal business with razor-thin margins. We don't adopt new materials just because they look pretty or, smell like pine. It has to make undeniable financial sense.
It comes down to 3 massive levers: speed, labor, and sustainability. Let's start with speed. Erection of a mass timber structure is 25 to 50% faster than a comparable steel or concrete building.
Wait, 50% faster. Let that sink in for a second. How are they physically achieving a 50% reduction in schedule?
Because you aren't building a structure from scratch on the site, you are essentially assembling a massive high-precision kit of parts.
Like Lego.
Exactly like Lego. The panels are manufactured off-site in a highly controlled factory environment using CNC routing.
And for those unfamiliar, CNC stands for Computer Numerical Control. It means a computer is driving a massive robotic router to cut the wood to millimeter tolerances.
Way more accurate than a guy with a tape measure and a circular saw.
Exactly.
So these panels arrive on the back of the flatbed with the window openings already perfectly cut out. The connection points for the steel plates are pre-routed.
Wow.
Sometimes even the mechanical chases, like the pathways for the plumbing, electrical, and HVAC, are already bored through the wood before it even gets off the truck.
That's incredible.
When it gets to the site, the crane flies it and the crew bolts it. That's it. Furthermore, it completely changes your labor profile.
Right, because you don't need all those guys.
No, you don't need rebar tiers. You don't need concrete finishers waiting for a pour to cure. You don't need dozens of welders. You need a highly skilled rigging and erection crew.
Which drastically reduces the number of specialized trades on site.
Exactly, which eliminates the scheduling bottlenecks and the constant coordination headaches that usually eat up a project manager's entire week.
So what does this all mean for the bottom line? Where is the real money made with this material? Because surely those beautifully engineered, custom routed panels aren't cheap to manufacture in a factory.
You're right. The raw material of CLT itself often carries a premium compared to raw steel or wet concrete. But you make it up entirely in the schedule savings, the reduced foundation costs from the lighter weight, and the vastly lower labor overhead on site.
It offsets.
Completely. In fact, Smart Business Automator's Market Intelligence Report pinpoints that the sweet spot for mass timber profitability is the 4 to 12 story range.
4 to 12 stories.
Yeah. In that specific bracket, it is highly cost competitive with steel, specifically for 4 to 8 story multifamily housing, educational facilities, and mid-rise office buildings.
That 4 to 8 story range is massive. I mean, that is the absolute bread and butter of mid-rise commercial development in every growing city in the country.
Oh, totally.
And there is another revenue angle here that developers are chasing right now, the sustainability premium. Developers are actually willing to pay a premium to build with mass timber because of its significantly lower embodied carbon footprint.
And this raises an important question about market drivers. Major corporations, tech giants, major universities, they all have incredibly aggressive ESG goals.
Environmental, social, and governance targets.
Right. They have made public pledges to be carbon neutral. Concrete and steel production are brutal on the environment. They account for a massive percentage of global greenhouse gas emissions.
Yeah, that is their embodied carbon. The carbon emitted just to create the material in the first place.
Exactly. But trees do the exact opposite. They sequester carbon.
You pull it out of the air.
They pull carbon dioxide out of the atmosphere as they grow.
Yeah.
So when you harvest that tree sustainably, turn it into CLT, and lock it into a building for a century, you are essentially creating a giant carbon sink.
And developers aren't doing this out of the goodness of their hearts, let's be real.
No, of course not.
They know they can charge significantly higher rents to corporate tenants who are desperate to occupy a certified green building just to meet their own corporate goals. It makes mass timber a highly profitable niche for early adopting contractors who can actually deliver these complex projects.
The demand is absolutely there, and the margins are there if you know how to execute.
Okay, let's unpack this. Knowing the why is great, but it naturally forces us to figure out the how. Because it's one thing to sit in a boardroom and say, hey, let's bid on a CLT mid-rise.
Much easier said than done.
And it's another thing entirely to transition your workforce, your superintendents, and your operations without stumbling and losing your shirt on the first job.
Yeah, the learning curve can be steep.
So how does a contractor actually enter this market successfully?
The first crucial step is understanding the supply chain and your division of labor. The heavy lifting of the engineering and the physical manufacturing is handled by specialized U.S. fabricators, companies like StructureLam and SmartLam.
Okay.
They handle the complex panel gluing, the CNC routing, the quality control, and the delivery logistics. They are handing you a finished, highly engineered component. This leaves the contractor to focus purely on the logistics of the erection and the sequencing.
But does a contractor need to go out and hire a completely new boutique workforce of specialized timber carpenters to do this? Because frankly, finding specialized labor right now is nearly impossible.
Not at all, and that's the operational beauty of it. There is a very direct skills transfer from steel erection.
Really? Steel guys?
Yeah. The primary skills needed on a mass timber site are crane operations, complex rigging, managing tight tolerances, and executing complex mechanical connections.
That sounds exactly like flying steel.
It is. You are dealing with heavy lifts and bolting steel connectors, like massive screws, steel plates, hidden dowels. A highly skilled steel erection crew can pivot to mass timber incredibly well because the fundamental physics of flying, catching, and setting heavy structural components are highly similar.
But here is the catch, and this is the administrative challenge I really want to highlight for the business owners listening today.
This is the danger zone.
Because this is where companies will bleed money if they aren't careful. If you're erecting a building 25 to 50% faster, that means your entire project management cycle is compressed by 25 to 50%.
Exactly.
You are navigating a flood of brand new specifications, entirely different RFI structures, requests for information, and incredibly fast timelines. Capturing that 50% speed advantage requires flawless project management in the trailer.
That is exactly where traditional contractors stumble. They try to manage a 2026 engineered timber project with 2010 administrative workflows.
Exactly. Imagine you're flying a massive custom-cut CLT panel into place, and your superintendent realizes the mechanical chase doesn't perfectly line up with the HVAC plans.
A nightmare scenario.
Right. With concrete slab, you shrug, get out a concrete saw, and cut a new hole. With a highly engineered CLT panel, you cannot just start cutting.
No, you might sever a critical structural load path.
You need an answer from the structural engineer immediately. And because the crane is costing you thousands of dollars an hour to just sit there, you need that answer in 10 minutes, not 10 days.
Yep.
If your office is stuck manually hunting through old emails to draft an RFI, you lose all the financial benefits of the material right there.
You absolutely cannot scale into this new building methodology, relying on fragmented spreadsheets and manual document hunting. The pace is just too punishing.
Which is why the sources specifically point to leveraging modern technology to manage this operational complexity. We're talking specifically about the extensive capabilities of Smart Business Automator as the essential tool here.
It's a game changer.
It is an AI-powered platform built to prevent your teams from drowning in administrative work when the pace of construction suddenly accelerates. Let's break down how this actually works for a complex mass timber job.
First, you have document intelligence and smart search. A mass timber project comes with highly complex shop drawings, thousands of connection details, and super tight tolerances. The Smart Business Automator automatically extracts all those crucial details from the new CLT specs the exact moment they are uploaded.
Oh, wow.
Your teams can use natural language search to instantly find exactly what they need. Instead of clicking through 20 nested folders on a tablet out in the sun to find the exact screw length and nailing pattern for a specific shear wall, a superintendent can just type the question and get the exact detail instantly.
That alone saves hours of frustration on the site.
Yeah.
And then there's the RFI assistance and compliance aspect, which solves that exact HVAC clash scenario we just talked about.
Exactly.
Smart Business Automator actually drafts RFI responses for you using historical project context, and it automatically checks your project information against those strict mass timber specs to catch expensive gaps early.
Long before the panel is ever hooked to the crane.
Long before.
It is proactive, not reactive. And because the timeline is so compressed, managing your risk and budget is hypercritical. The platform's schedule risk detection and budget insights are constantly analyzing the live project data.
What kind of risks does it catch?
They spot bottlenecks, like a delayed panel shipment from the fabricator, or a sequencing error in the erection plan, way before they derail the critical path. Furthermore, its change order impact analysis evaluates how any single change will ripple out and affect both your timelines and your costs.
Allowing leadership to make informed decisions immediately instead of guessing.
Exactly.
And keeping the field and the office on the exact same page is handled by the project health features. We're talking about daily log summaries that the AI literally writes for your superintendents, automated executive reports for the owners, and deep API integrations with your existing ERPs and accounting software.
Everything talks to everything else.
It ensures that the field crew repping the wood panels and the office team managing the cash flow remain totally aligned as your business scales into this new sector.
If we connect this to the bigger picture, the commercial construction industry heavily rewards those who adapt, and it ruthlessly penalizes those who refuse to evolve.
So true.
We are moving away from brute force construction, pouring wet concrete and waiting for it to dry, into precision assembly.
Right.
The contractors who master mass timber logistics and leverage AI platforms to manage that massive operational complexity are the ones who are going to absolutely dominate the commercial market for the foreseeable future.
So what does this all mean? Let's do a quick synthesis of this paradigm shift. Mass timber, specifically cross-laminated timber, gives you a material that is structurally equal to precast concrete, but at 1/5 the weight.
Huge advantage.
It allows your crews to build 25 to 50% faster with significantly fewer specialized trades clogging up the site.
Yep.
It chars predictably in a fire, insulating its core and making it incredibly safe, which is why the IBC officially allows it up to 18 stories tall right now.
The code is on your side.
And to top it off, it commands a massive sustainability premium from developers chasing corporate ESG goals. It is a financial win across the board, but only if you have the operational discipline to execute it.
It is a massive opportunity for top-line growth, but it completely requires that operational discipline and the right technological infrastructure to support it.
So I want to leave you with a final provocative thought to mull over today as you head back to the site or the office.
Man on them.
If engineered wood is already safely replacing heavy steel and concrete in 18-story skyscrapers today, what other traditional materials sitting on your job site right now are going to be completely obsolete in 10 years?
It's a great question to ask yourself.
To all the construction business owners in the Scaling Legends audience, thank you for joining us on this deep dive.
Thanks for having me.
If you enjoyed this analysis and found it valuable, please subscribe to Scaling Legends on your preferred podcast platform. Leave a rating and a review to help other ambitious contractors in the industry discover the show.
Please do.
Share this deep dive with your colleagues, your project managers, or anyone on your team who would benefit from understanding this huge shift in the market. And finally, to scale your business, confidently manage these complex new builds, and stop drowning in admin work, visit smartbusinessautomator.com.
Keep building the future.
We'll see you next time.